So here we had a very exciting project where paleontologists approach us to ask us, hey, we have this fossil of a very old animal, the Orobates, and we have the full fossil and we also have footprints of that animal. And the big question was to see what was the most likely gait, way of moving of that very old animal. And there it was very interesting for us to make a robot and a complete simulation of the morphology and very systematically explore all possible gaits, all possible ways of moving in these footprints.
First, with our collaborators in Humboldt University of Berlin, they create an animation, which is a kinematic model of the fossil. And with that animation, we understood which are the three main characteristics of a sprawling locomotion. In this case, we have, for example, how close we are to the ground or how erect we are. Second is how much you bend the spine when you move. And the third one is how much you use this joint or how much you use this joint. To validate the kinematic model, we use modern species, a skink, a salamander, an iguana, and a caiman. And what we did was take X-rays of these animals while they were walking, and with this we create a set of data that allow us to basically validate that this space makes sense. Then the second part was the dynamics part, which is the things that we do with robotics, and is creating a robot. And out of this robot, we create a simulation in order to test all this physics. So basically, we recreate a certain amount of gates in that space. And with those gates, we tested which these gates behave under 4 metrics. The fossil that we were recreating, the Orobates, is a very important animal in evolution. From that animal, the reptiles, the birds, and mammals, including us, come from.